Hello everyone, welcome to my YouTube channel. I am Mithun, currently studying in Sri Venkateswara College of Engineering, Bangalore. In third sem, today I am going to discussing about operating system. In that, uh, we're going to talk about file system structure and operating system. So let us understand the layers, components, and the modern application in this. So here, a pictorial representation describing about files, file system, and operating system. So generally, the files are stored in the file system, where operating system uses and whatever the requirements is needed is done between the file system and the operating system. So let us move on to our topic, the file system. A file system is a method that's going to be used by an operating system to organize and store the files on storage devices. So here we can see it is a local file system and a network file system here and a client. So here is a storage, you know, mask, and we have file system and a client. So file system act as a intervene or midway between the client and the mass storage. So here we can see that the hierarchy of the file system that can be workflow of it. Here we have hard drive, partition, file system, directory, and files. So it ensures the data organization, retrieval efficiency, and resource management. So in that, we're gonna discuss, we're gonna talk about a disk. A disk is the file system, uh, generally present in the file system. We can refer it to as a physical storage devices like a hard disk drive, that is HDD, or solid state drives, where data is stored. And the disk is divided into several logical units for managing and organizing the data. Here in this diagram, we can see the hard disk drive structure where they have been segmented and divided into several logical units for organizing the data and also managing the data here. Here, the circular one, we can see it is a track, whereas this is a cluster and an yellow color representing the sector. This is how exactly the hard disk drive structure look like. So, basic characteristics of the disk, we can rewrite in a place. So there will be a write where we can modify the block directly on the disk, and any block can be accessed sequentially or randomly, and there will be a transfer of data, block based transfer we can call it as, and data will be moved in blocks. So typically a sector consists of 512 uh, bytes of blocks. The file system design problem. So in this we have two perspective. One is user perspective, another one is system perspective. And in user perspective, we can see the files, attribute, operations, and directory structure. When we talk about files, it's a collection of data or the information that can be stored on a computer. Whereas attributes are the characteristics of files like name, size, type, and creation data. And when we talk about operations, so we can perform like various operation in the file system like creating the file, reading the file, writing the file, renaming the file, and deleting the file. Directory structure. It is a file system in which we can organizing and storing of files and the folders going to be takes place in it. So we say that a directory structure in a file system is a way of organizing and storing the files and the folders On a computer or storage device. Storage device is HDD. When I talk about system perspective, in a file system, algorithm like a node-based system, they're going to be map logical structures to physically storage location, ensuring efficient data retrieval. So when we talk about data structures such as file allocation tables, that is FAT, and indexed location, they're going to be helps in managing and mapping between logical addresses and physical blocks on the disk. So layered file system design, we can it been represented in this flowchart. So a layered file system design will organize this system into different levels. So each level, the each layer within that level has a specific responsibilities, and each layer builds on one below one like this, and adding an extra functionality or complexity. So it helps in order to reduce repetition of the code, since each layer focuses on unique task, but it can also introduce some overhead, mainly because the data might need to pass through several layers. Okay, it before it reaches its destination, that is the device. So um, repetition of code should be there. So we can say that it makes system easier in order to manage and extend, but can be less efficient due to multiple layers are going to be involved in this layered file system design. I/O control layer. So when we talk about I/O control layer, it's a part of the computer system which going to be helps in managing the you know communication between system and the devices. So devices in the sense like hard drives, keyboards, printers, etc. Here are the two components that comes under I/O control layer, that is device drivers and interrupt handlers. If we talk about device drivers, uh, these are the special program that act as a translator. So it will take the commands from the computer. Here, for example, read block 123, that is from the disk, and it's going to be converted into action that the hardware understands. So, like example, as AAK. It's an action that's going to be understood by the computer, whereas the command that's going to be given by us, it's a read block 123. So this is a translator that's going to be translate, that is device drivers, and it tells hard drive exactly how to do it. So another I/O control layer is interrupted handlers. So devices like hard drives need to communicate between the computer. Okay, when they are ready to give away their data, available data. So interrupt handlers are like managers in it. So they handle this communication by stopping the computer current task, processing the information, and it will continue where it left off. And here we have when the data is read from the disk, the interrupt handler ensures that memory gets the data. So we can say that I/O control here makes sure that the computer can talk to and understand all its uh, functionalities. So another thing we need to discuss is basic file system. So it's a fundamental part of an operating system that helps to manage how files are stored and accessed on a computer or a device. So here we can have a number of uh, simple terms here, like issues, commands to device drivers, manages memory buffers and caches, and we have tracks frequently accessed metadata. First on list is uh, First on our list is issue commands to device drivers. When you want to access a file system sends a command to hard drive. So like hard drive, previously been known as hard drive like HDD and SSD. They're going to be, sends the command to the hard drive through device drivers, so which are special program that control the hardware. So manages memory buffers and caches. Now we have manages memory buffers and caches. It keeps the track of temporary storage areas like buffers and the caches. They're going to be hold data while it is being transferred. It also improve in performance by reducing the time needed to access the data. So we have tracks frequently accessed metadata. So metadata is the information about the files like name, size, and the location. So generally the file system keeps the track of this metadata, especially the files that are accessed often. So it can be find them faster. So the basic file system it helps in organize and manage how files are stored, accessed, and quickly retrieved. So we have file organization module. It's a part of computing system that helps in managing the files and their storage. So we can see the translate logical block address to physical address here. So when a file is saved on a storage device, it will be broken into small pieces, what we call it as blocks. Each block has a logical address like label or ID number. They're going to be used by the system to keep track of it. So file organization module helps in, uh, you know, it will takes a logical address and translate it into physical address. So the system exactly know where the storage device that the data going to be located. Then we have a track free space using a free space manager where a storage device has a limited space. The free up space manager keeps track of which part of the storage are empty, like free space, and which is already occupied by the data. So this helps the system efficiently in order to find space to store new files. So manages file allocation. When a new file is created or an existing file grows in size, the system need to allocate space for it. The file organization module decides where to place the file blocks on the storage device and ensures that the file is properly organized for reading and writing. We can say that module helps organizing the files, tracking and managing where how files are stored on the devices, ensuring that data is properly allocated, addresses are correctly translated, and space is used efficiently. So here we have file system types that we talk about. We see disk-based file system, removable media file system, disturbed file system. In disk-based file system, we have NTFS, extract 4 FAT32. Removable media file system, we have ISO 9660 for CD-ROMs. And we have distributed file system where we have NFS again, and Google file system we do have here. So what we can see the innovation file system is Google file system and Fuse. So In Google File System, it will optimize for high performance across many disks, whereas in Fuse, it's a user level file system implementing for flexibility. Um, Next, we have challenges and considerations. In this, we have performance versus layer overhead will be occurred in the file system. And another challenge we have is file system security and access for the permission. And last not the least, we have managing scalability for large scale data. This is what we consider going to be consideration and challenges here. So in conclusion, we say that file system bridge a bridge between the user level and the hardware level storage. So the layered architecture improves modularity. So the innovation continues with new file system like Google, FS and Fuse. Thank you all.